Composition of reflections. The composition of reflections means that a pre-image reflects over two lines, a first line, L1, followed by a second line, L2. So see, this pre-image is reflected there, and then it's reflected again down there. The composition of reflections means that a pre-image reflects over two lines, a first line, L1, followed by a second line, L2. For example, here's an example of the composition of two reflections. The pre-image was reflected over the line y equals 0 after it was reflected over the line x equals 0. This means reflect over the x-axis first and followed by the y-axis second. For our purposes, we will reflect across vertical and horizontal lines only. Here's another example. So we have this notation here, and this means that it was reflected over the x-axis, where y equals 0, first, and then the y-axis second, where x equals 0. Question: what appears to be true? The composition of reflections, one across the x-axis and the second across the y-axis, in either order maps to the same image. The composition of two reflections, one across x equals 0 and the other across y equals 0, is given by r sub y equals 0 after r sub x equals 0, which equals the same thing in the other order. The order of composition doesn't matter. Both orders result in the same image. So here we start with our pre-image, reflected here and then there, or start with your pre-image, reflected down there and then over. In general, is the composition of reflections commutative over one vertical and one horizontal line? All right, let's draw on the grid the compositions given by these two equations here. Do these two compositions map onto the same image or different images? All right, so let's check. We have our pre-image. So we're going to first reflect it over the line y equals -1. So let's draw that line. When y equals -1, oh, that's right here, so I'll just highlight it in green. So let's reflect it over that line first. So 1, 2, 1, 2, 1, 2, 1, 2. So we have this line here, and then like that, 2 over, and then 4 up, like that. Okay, then we're going to reflect it over the line x equals 6, so I'm going to highlight that in red. Here's x equals 6. All right, so we have reflected over this line. So there, and then this is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. All right, so I can draw it now. All right, so now let's do this order. So first we're going to reflect it over the line x equals 6. So that would be here, like this. So right now I'm reflecting this image across the line x equals 6. All right, and then reflect it over the line y equals -1. So yes, we do end up with the exact same, place at the end. The answer to this question was yes. In general, the composition of reflections is commutative over one vertical and one horizontal line. The order of composition doesn't matter. Both orders map to the same image. Click the Desmos icon to access a website that demonstrates the composite of reflections.